Hi guys, good morning. So in the last session, we saw about, we started with the STP, then we saw STP introduction, and we were going with, some of the filtering mechanisms like, we had seen about BPD filter, then root guard. Okay. And why this is not saved? Root guard is there. Okay, I guess I have directly shown you the practicals. Like we went with the loop guard. Okay. After root guard, we went with the loop guard. We saw about UDLD. We saw about port priority concept. Before port priority, we saw that how we can change the STP path cost. Okay, this thing we saw. Then we saw about direct link failure and indirect link failure. These are the things we saw in the last session. Now today we will be starting with the RSTP. Okay. So we know that the STP, it takes an amount of time, right? It takes some amount of time, which is about how much time? 50 seconds? Yes or no? Everybody agrees?
Yes, sir.
Right. Guys, give me one moment. Okay.
Sir, one doubt in STP.
Mm-hmm.
Here we are explaining three switches, right?
Yes.
In topology, suppose we have a bigger topology.
Mm.
Only one root bridge is there, and all other switches are non-root bridge switches, right?
Yeah, that will be the case actually.
Okay, so only two designated port as well, right? Suppose in a
Yeah.
hundred switches is connected in a topology, there will be a one root bridge and a two designated port, right?
Yeah, on the root bridge, whatever the number of ports are connected, all those ports will be designated ports only.
In a bigger topology also, a single root bridge.
Yeah, but you see in this topology, if you count the total number of designated ports, we have three, one, two, and three, right?
Oh, yes, yes. Okay, okay.
Yeah. So on
Okay.
the root bridge, the number of ports are there, that many ports will be there. But
Mhm.
also you should know that every single link will have a designated port.
Okay, okay.
Hmm.
Okay, sir. Thank you.
Yeah. Now we know that STP takes how much time? 50 seconds. So we needed faster conversions. And this is where we required what? Your RSTP protocol. Okay. So if we talk about RSTP, RSTP stands for Rapid Spanning Tree Protocol. Okay. This is your RSTP. And the reason your RSTP protocol was designed because we require less number of less amount of time, right? We say that okay, it helps in faster conversions compared to your PVST, or you can say your STP. This is clear. So let's talk about few of the differences between your, PVST, I mean your spanning tree and your RSTP. So if we talk about the difference, so on one side, difference between STP and RSTP. So on one side, we have STP, and on the other side, RSTP. Okay. So if we talk about the differences, right? So here we can say that first of all, your STP has IEEE code 802.1D, right? The IEEE code for your STP is 802.1D, while the code for your RSTP is IEEE 802.1W. Okay. Then if we talk about if we talk about the port states, right? So in case of RSTP, in case of STP, we have the port states, that is disabled, listening. Okay, before that we have blocking, blocking, listening, learning, and forwarding. Okay, these are the states. While if we talk about your RSTP, so in RSTP, if we talk about port states, so RSTP port states are
Disabling, learning, and forwarding.
number one is discarding,
Discarding.
then we have learning and forwarding. Okay, these are the states. So this discarding state, this is kind of, you can say similar to your disable blocking and listening. Okay. Then if we talk about port rules, okay. So here we have designated port. So in short, if I mention designated port, root port, and alternating port, right? These are the port rules. While here, here we have the port rules. Designated port, root port, alternating port, and we have one extra, which is backup port. Okay. So we'll discuss about all these port rules also. What are these port rules? Okay. Then after, if we talk about your STP.
Sir, in STP port roles,
Mm-hmm.
we don't have alternate port. No, so I think we have block port only.
No, alternating. Okay, that is blocking is the state.
Okay.
Okay, blocking is the state. The role is alternating port only.
Okay.
Yeah. Then after we have, like here we have slow convergence. Okay. And here we have faster convergence. Okay. Here we have faster convergence. This is clear. And your STP works based on timers. Okay. In STP, we have timers like MaxAce timer. We have, some other timers. And your RSTP majorly works on the negotiation mechanism. Okay. Like how the root bridge will be there, or which port will be forwarding, which port will be discarding. So that will be decided by the negotiation mechanism. Okay. So as of now, you can keep these three things as a differences, or these 4 differences. More about it, let's discuss about the RSTP. Okay. So let's move into the lab. This is taking how much RAM? Two. Which is free. 45. Meanwhile, the UNG is coming up. Let's go through the documents. Okay. So rapid spanning tree protocol, IEEE 802.1d has only one topology tree and a slower convergence, which can be problematic, which is about STP. So RSTP, that is IEEE 802.1w, reduces the number of port states to be faster and more efficient. Okay. So you see here that your normal STP, which is 802.1d, again, that is having a slow convergence, only one topology. This can be problematic, and larger environments with multiple VLANs, they need different STP topologies. Okay, for traffic engineering purpose. So what Cisco did, Cisco created the proprietary PVST and PVST plus. So RSTP 802.1w reduces the number of port states to just 3. That is discarding, learning, and forwarding. If we talk about discarding state, The switch port is enabled, but the port is not forwarding any traffic to ensure that the loop is not created. Then we have the learning state. The switch port modifies the MAC address table, and the switch does not forward any other traffic besides BPDU. Okay, and here what is happening? That the switch port forwards all network traffic in the forwarding state. So this is the final state. Okay, so these are the states of the RSTP, only 3 states. Okay, and as per our comparison, if I look like, right? So let me just go here. Okay, something went wrong. So that means what? Basically, your discarding state, this is equivalent to your blocking as well as listening. Okay, these 2 states are combined into 1. Okay, this is the case. Okay, and these are the port states. So next is about the port rules. So we see we have root port, designated port, alternate port, and backup port. Okay, so a root port. So what is a root port? A network port that connects to the root bridge or an upstream switch in the spanning tree topology. And there should only be one root port per VLAN. Okay, there should be only one root port per VLAN. So on a switch, for a particular VLAN, there will be only one root port. Why? Because the root port is the shortest path coast path to the root bridge. Okay, so for particular VLAN, for one VLAN, there will be only one root port on a switch. Then we have designated port. Okay, so what is this designated port? A port that receives and forward BPDU frames to other switches. Okay, and the designated port provides connectivity to downstream devices and the switches. And there should only be one active designated port on a link. Okay, same like that on a root bridge. All the ports are designated ports, right? Then after, first of all the ports of a root bridge are what? Designated port. Then each link should have a designated port. Okay, so every single link should have at least one designated port, and that is given here, that there should only be one active designated port on a link. Then alternate port is there. That means the port which is not a root port, which is not a designated port, that will be what? Alternate port, and this will be the blocking port, right? So a network port that provides alternate connectivity towards the root switch through a different switch. Okay, so here this is the alternate port. Then what is the backup port? Backup port, a network port that provides link redundancy towards the current root switch. Okay, and a backup port exists only when multiple links connect between the same switches. So earlier we were having conditions, like what kind of scenarios we were having? Let's say you have two switches. Okay. So in these two switches, if two links are connecting between the same switches, okay, then one of the link will be what? Or one of the port will be what? Backup port. Okay. And this thing here, alternate port. Okay. So in case of, STP, we were having the alternate port. That alternate port is what? This is the port that will be what? Blocking, and it provides a separate path. Okay. It provides an alternate path to the root bridge through a different switch. So how the definition is different? Look at this diagram here. Okay. Our previous diagram. So think about this switch 3, right? So here, this is the alternate port. Now, switch 3 right now, it is having a connectivity to the root bridge directly via Z0 by 1. But also there is one more path that is through the alternate port. So this is providing what? An alternate path. Is that clear? This is an alternate path. Okay. So these are the port rules. Guys, any doubt in the port rules? Yes or no?
No, sir, it's clear. But only one
Mhm.
doubt.
Mhm.
This alternate port,
Mhm.
will there not be, I mean, looping, because you are saying
Yes, but
alternate connectivity.
it will not forward the traffic, right? It is providing us an alternate path. Okay, but it will not be forwarding the traffic. Otherwise, if alternate path will also forward the traffic, then there will be a problem. Loop will be there, and we want to avoid the loop.
Then you will be putting a conditional. So you need to have that BPDU guard, right? Or root
No
port
need,
guard,
no
right?
need, no need. No need here. This is already blocked, right? The port is
blocked at that moment of time, right? Maybe about for 15 seconds, right? So unless until
sorry,
your
come
root
again.
bridge, so it is blocked for a certain period of time, right?
No,
For
no, no,
15.
no, no. See, if this port is there that is forwarding the traffic to the root bridge, so this port will never forward it. This port will not be forwarding any data traffic. Okay.
Okay.
Yeah. This will not forward any data traffic. Otherwise, definitely there will be a loop. Is that clear?
Okay.
Yeah. So once we are going with the practical, there will also, it will be clear. So these are the port rules. Any other doubt in the port rules? Okay. Then there are some extra port rules also. Okay. Other than these, we have some port rules: root port, designated port, alternate port, and backup port. Now there are three extra port types. So RSTP defines three types of ports that are used for building the STP topology. Okay. So edge port, root port, okay, and point to point port. These are three extra port types. Here, see, we have some port rules, okay, and these are what? These are the type of ports, okay. So what is the edge port? A port at the edge of the network where your hosts are connecting. That means where your end hosts are connecting. These are what? These are the edge ports, okay. And where the host connect to the layer 2 topology with one interface and cannot form a loop. Okay, so these ports directly correlate to the ports that have the STP port fast feature enabled. Because we know that the ports where the end hosts are connected, we enable those ports with the port fast, so that we don't have to wait for that time, right? 50 seconds. Or in case of RSTP also, even though few seconds, we don't have to wait. Then we have the root port. So root port is what? Root port is the port that is providing the best path coast towards the root bridge. That means shortest coast path to the root bridge. Okay. And there can only be one root port on a switch for a particular VLAN. Then we have point-to-point port. So what is point-to-point port? That means when a switch is connecting to another switch. Okay. So any port that connect to another RSTP switch with full duplex. Okay. So full duplex links, they do not permit more than 2 devices on the network segment. So determining whether a link is full duplex is the fastest way to check the feasibility of being connected to a switch. Okay. So what here they are trying to say is a point-to-point port is what? Where 2 RSTP switches are connected to each other and they are working on full duplex mechanism. Okay. So these are the 3 types of ports that you're going to see. Okay. That means where do you see these port types? See here. If I say this is STP. Okay, in the same topology only we will see. We don't need this one. Backup port we can see. Start all the nodes. And first wipe all the nodes. Start again. So switch 1. Switch 2. Switch 3. Switch 4. Switch 5. Now while these switches are coming up, let's move further. These are the port types. So here it says that this is the point-to-point port. And if you have multi-access connections, that means if you are having hub, in that case, you have to use STP. You cannot use RSTP there. If you want to, like, if you do not want to use point-to-point. Then this is about the mechanism. Okay. So we'll come. Okay, let's go through the mechanism, then directly on we will see the lab only. So RSTP switches, they will exchange what? Handshake with other RSTP switches to transition through the following STP states faster, right? So they will establish a bidirectional handshake across the shared link to identify the root bridge. That means, like I said, that your STP, okay, it works on what? Negotiation mechanism. So if you have 2 switches, first of all, your switch, like as the first 2 switches connect to each other, they verify that they are connected with a point-to-point link by checking the full duplex status. Okay, so first they will check this. Then after, what will happen? There will be a proposal and there will be a agreement. Okay, so it works on the proposal and agreement mechanism. Okay, so they are going to establish a handshake with each other to advertise a proposal. Okay, like I said, proposal has been advertised that their interface should be designated port. That means they will consider whatever the first switch is there, it will consider that I am the root bridge, so my port should be designated port. So they will establish a handshake with each other to advertise a proposal, okay, telling that their interface should be the designated port. But there can only be one designated port per segment. So each switch will identify whether it is superior or inferior switch using the same logic, like, lower priority, lower MAC address. Okay, they will use the same thing, and then the root bridge will be elected. Then The inferior switch will do what? It will recognize that, okay, it is inferior, and it will mark its local port as the root port. Okay. At the same time, it will move all the non-edge ports to a discarding state. Okay, so all the ports where like STP port fast is not enabled, so those ports will be put to the discarding state. And at this point in time, the switch has stopped all local switching for non-edge ports also. That means all the communication has been stopped for the non-edge ports. Okay. The inferior switch sends an agreement. So switch 1 sent a proposal, switch 2 is sending an agreement to the root bridge, which signifies to the root bridge that the synchronization is occurring to that switch. Okay. And then inferior switch will move its root port in a forwarding state, and the superior switch will move its designated port in a forwarding state. And then the inferior switch will repeat the process for any downstream switches connected to it. Okay. So simple, if you understand. So if you have two switches, we have two switches. Okay. So first of all, switch 1, let's say this is switch 1. And this is, let's say, switch 2. Okay. So if they are connected, so first of all, both the switches, they will send what? Proposal. Okay. They are sending what? Proposals. And in the proposal, they are saying that switch 1 is saying my port should be designated port, and this switch is saying my port should be designated port. Okay. Once they will see, so they have received each other's proposals, they will compare that, okay, who is superior, who is inferior. Okay. So let's say switch 1 is having the lower priority than switch 2. So switch 2 will do what? It will see that, okay, I am the inferior switch. Okay. So all other non-edge ports, that means all other ports where other switches are connected, all those ports switch 2 will put in the discarding state, and it will stop all the communication. Okay. Then after, this switch 2 will do what? Switch 2, once it has put everything in the discarding state, it will send a agreement to the switch 1 that, okay, I am synchronizing, okay, the configuration. Okay, I'm performing synchronization and you are the root bridge. So that information it will give. After that, your switch 2 will put its own port in the as a root port. This port will become the root port, and it will put this port in the forwarding state. And once this agreement has reached here, so this guy, switch 1, will it put its designated port. This port is the designated port, and it will put this port in the forwarding state. And then if any other switches are there, so switch 2 will, they will also follow the same process, proposal and agreement. Okay. Is that clear? Yes or no? Guys, this process is clear.
Yes, sir.
All right. Now let's see. Switches are up. Enables configuration terminal, host name, switch 1. Exit. Also, let me change the mode. To change the mode, we will just use the command spanning tree mode. And you can see we can give here rapid PVST. So rapid PVST is what? RSTP only. Name, switch to spanning tree mode, rapid PVST. Host name switch tree, spanning tree mode, rapid PVST, switch 4, host name, switch 4, spanning tree mode, rapid PVST. Host name, switch 5, spanning tree mode, rapid PVST. Okay. So we have changed the mode. Okay. Now let's take a look. If I say show spanning tree, so I can see the protocol running is what? RSTP. Okay. And this bridge is the root. So switch 1 is the root bridge. And all the unwanted ports, I will just disable them. Okay. So let me mention the comment here. Interface range Z0 by 2 to 3, V1 by 0 to 3, shutdown, exit, exit. Okay, everywhere, all the unwanted ports I have shut down. Now, if I say show spanning tree, we can see that switch 1 is the root bridge and both the ports are as a designated port. So if you see, this is the role of the port, designated port, and this is the state of the port, that is the forwarding. Okay, and this is the type of interface. So right now, what is the type of interface here? Point to point. Point to point means this is where a switch is connected. Okay. Then this one, that is switch 2. If I say show spanning tree, so here we have Z0 by 0. This one as the root port and this one as the designated port. Same like STP. Okay. And same port type is what? Point to point. Then after switch 3. Show spanning tree. So here, this port is the root port. This port is the alternating port. And again, port type is what? Point to point. Okay. And you can see protocol running here is RSTP. And now what? Let me show you about the backup port. So that backup port will be available between switch 4 and switch 5. So between switch 4 and switch 5, switch 4 is the root bridge. So if I say show spanning tree, you can take a look that here RSTP is running and switch 4 is the root bridge. So both ports are designated ports. And here show spanning tree. Okay. So here, this is the alternating port and working as a block port. Same thing here. Okay. But this port itself is the backup port also. Okay. If you see here, what is the backup port? That provides link redundancy towards the current root switch. Okay. A backup port exists only when multiple links connect between the same switches. Okay. So that means in this case, I have only, you can say I have only 2 links. And what I can do is, this is the alternating. So it will show as alternating port only. Okay. Because the link will get blocked. Okay. This is clear. Any other port where you will connect end host, so that will be given as a edge port. Okay. Any other port where you will connect the end host, that will be given as a edge port, and root port and point to point we have seen. Okay. This is clear. Okay. Then next thing we have to discuss about the multiple spanning tree.
Sir,
So
here
here,
also alternating port and block port actually it is one port only, but
yeah, correct. So
two definition.
block port is, see, blocking is a state.
Okay, okay.
Okay, that is
But here it's a backup port as well, right?
backup port. But this backup,
Comparing to STP.
mhm, correct.
Okay.
Okay. So alternate port will be the port that will be blocked. Now, uh, how to change the mode? Change the STP protocol to RSTP. So how you can change? You can say spanning tree mode rapid PVST. By default, in your Cisco switches, PVST is running. So if you want to run RPVST or rapid PVST or RSTP, in that case, you will use this command. Okay. Next one is about MST, that is multiple spanning tree. So let's talk about it. So next is about multiple spanning. Okay. So your multiple spanning tree, first of all, the IEEE code here is 802.1s. Okay. And why MSTP was designed? Because in STP and RSTP, what was happening? That only one STP instance was there. Okay. One STP instance was there for all the VLANs. That means for all the VLANs, you can say kind of only one root bridge calculation was there. That is the problem. So with the help of MST, what happened? That we are capable of using single STP for a group of VLAN. Okay, that means let's say you have 100 VLANs. So for VLAN 1 to 10, you have one root bridge. For VLAN 11 to 20, you have a second root bridge. For 21 to 30, you have another root bridge like this. Okay, so for a group of VLAN, we can do what? We can use a single STP. Okay, rather than using it for all of them. Why? Because if all the VLANs will use the same STP single root bridge, so that will cause a lot of CPU overhead. So we don't want that thing, right? So what we say here, that you can say with the help of MSTP or MST, we can use a single STP instance for a group of VLANs. Okay. And your MST works on the concept of regions. Okay. MST works on region concept. Region is what? Basically kind of a group of switches. Okay. So let me open the document for MST. So the original 802.1d standard only supported one STP instance for an entire switch network, which means it was not possible to load share traffic across links by blocking for specific VLANs on one line and blocking for other VLANs on alternate links. That means we are not able to, like I said, CPU overhead was very high and we were not able to perform any kind of load balancing also. So with the help of MST, okay, maps one or more VLANs to one in STP instance. Okay. Then here you can see this is a common spanning tree where, only one root bridge is there. Okay. So it doesn't matter how many VLANs are there. Even if you have VLAN 1, 2, 3, 4, they will share the same topology. While PVST does what? In case of PVST, per VLAN, every VLAN will have the STP topology. See, in a common spanning tree or in a STP, all the VLANs will have same root bridge. Okay, only one calculation. But in PVST, for each VLAN, there is a calculation. Okay, but what is the case? With MST, what we can do, we can say VLAN number 1 and 2, they will have this topology, VLAN 3 will have this topology, and VLAN 4 will have this topology. Like this, we can have it. Okay, that means for a group of VLAN, we can use a single root bridge or a single STP instance. Okay. Now, what is a MST region? So MST region is what? A group of MST switches with the same high level configuration is known as a MST region. So MST incorporate mechanisms that make an MST region appear as a single virtual switch to external switches. So one MST region will kind of look like a single switch only, single virtual switch only. Okay. But what is the region? Region is just you can say a group of switches that are running the multiple spanning tree. Okay. Which are running the MST protocol. Okay. So this is what a region is. So MST works on region concept. And what is an MST region? This is a MST region. MST region. Okay, so MST region is nothing but a group of switches which are running MST. And there are some criteria for having a region also. That means what switches will participate in the MST region. So if we talk about MST region criteria, okay. So first thing, your region name must match. Okay. Whatever the region name you're configuring, that region name must match. Number two, there is a revision number that we are going to configure. That revision number must match. Okay. This must match. And the instance to VLAN mapping must match. Okay. So these are the things that must match. Okay. These are the things that must match in a MST region. So that means all the switches in a MST region, they should have the same region name configured. They should have the same revision number configured, and everybody will have same instance to VLAN mapping. So I'll explain you what is instance to VLAN mapping also. Okay. So commands are also simple. You just change the mode, that spanning tree mode MST. Then after, you see here, if you want, you can configure priority also. Okay. If you want, you can configure priority. So according to the priority, what will happen? That a particular root switch will be elected. Okay. Then spanning tree mode MST instance number, you can also use the command root primary secondary. Remember the same thing we had in the CST also. So same concept is there. Okay. So this concept is also same, that priority is between this one and it has to be increment of 4096, and the primary keyword will reduce your the default priority. We know that 32768 it is there. So the primary keyword will reduce 8192 and the secondary keyword will reduce 4096 from the default priority. Okay. And what happens as soon as you create, as soon as you enable MSTP, there will be one instance created by default. Okay. By default, one instance will be created, which will be instance 0. The default instance that is created is what? The MST 0. So associate VLANs to an MST instance, and by default, all VLANs are associated to the instance, which is MST 0. Okay. So the MST configuration submode can be entered. So you can use this command to enter the MST configuration, that spanning tree MST configuration. And then we can use the command instance number, VLAN, and VLAN ID to map VLANs to a particular instance. Okay. So these are the commands. Then if you want, you can also give the revision number. So you can see, you can specify the MST version number. The MST version number must match for all the switches in the same MST region. So the MST version number is configured with the sub command, that is revision and version number. Okay, so that means you can use the command like this, revision, and the revision number must match. Then after, if you want, you can also configure the name of the MST region, and this name must be same. Okay, so define the MST region name. MST regions are recognized by switches to share a common name. By default, a region name is empty string, and the MST region name can be configured with the command MST region and name, and you can configure the region name. Okay, then if you want to check the configuration, so you can use the show spanning tree MST configuration, or show spanning tree, or show a spanning tree MST and instance number, or particular interface characteristics also we can check. Okay, so let's see these things. First of all, let me mention the things here so that it will be easier for you to refer. So I'll say here that as soon as we enable MST, one instance will be running by default, okay, which is instance 0. Okay, this is instance 0. Okay, and by default, all VLANs will be mapped to the instance 0. Okay, this is clear. Now, let's go and check in the topology. So what I'm going to do is I'm going to say so this configuration sometimes works and sometimes doesn't work. Let me do one thing. I'll just enable configuration terminal spanning tree mode MST. Okay, only this command right now I'm giving to change the mode and with the default configuration. Okay. Now let's check. If I say show spanning tree, So first thing you can see that here the number is what? MST 0. The number is MST 0. MST 0 means this is the instance 0 running. Okay, this is the instance 0 running. Then here show spanning tree. Here also you can see instance 0 is running and switch 3. If I say show spanning tree, here also you can see instance 0 is running. Okay. And right now we don't require switch 4 and switch 5. Okay. So by default instance 0 is running. And now if I want to see the MST configuration, so I can use the command show spanning tree MST configuration. And I can see that by default, my instance 0 is there and all the VLANs from 1 to 4094. All these VLANs are mapped to instance 0 only. All these VLANs are mapped to instance 0 only. Okay. The name is not configured for this instance. The revision number is 0 and total instances configured is 1. Okay. Then if you want more information, you can also use the command, show spanning tree. Okay. And MST interface, not interface, we can MST 0. That means about the instance also you can have more information. So I said MST 0, I need to check. So in the MST 0, say this is the MST 0, these are the VLANs configured. This is the default priority. Okay. This is the bridge ID. Okay. Then these are the port states. Okay. And this switch is the root. Okay. So you see this switch for the CIST, that means internal spanning tree. Okay. So that means for this particular instance, this particular switch, that means the switch 1 is the root bridge. Okay. Now if I check on switch 2, same thing. Show spanning tree MST 0. So you can see here we will have the information about the root bridge also. That okay, the root bridge is this. With this address, with this priority, this on this port it is connected, and this is the path cost. Okay. Then after you can see that okay, regional root. So this for this particular region, same switch is the root bridge also. Okay. Now, what about we do the configuration? Okay. So if I go and do the configuration, if I say configure terminal and see, in case of MST, what I'm going to do is I'm going to configure VLANs. Multiple VLANs I will require, right? So I'll say VLAN, let's say 10, VLAN 20, VLAN 30, VLAN 40, VLAN 50, VLAN 60, VLAN 70, VLAN 80, VLAN 90, VLAN 100. Okay, these are the VLANs. Then mode we have already changed. Okay, so what I'm going to do is I'm going to configure here. I'm going to enter the MST configuration mode. So let me do one thing. I'll show you this thing directly on the switch. Copy, paste. Okay. So how do you enter the MST configuration mode? You use the command spanning tree MST configuration. This is the MST configuration mode. Now here I can configure the name of the region, that let's say this is NHCCNP. Okay. Let's say this is the name of the region. Then after revision, I need to configure. So revision number I can configure 0 to 65,535. So let's say I'll configure revision number 1. Okay. Then how do you map instance to a VLAN? So let's say I'll say instance, then I'll give the instance ID. So let's say 0 is already there by default. So instance number 1, VLAN, and let's say I want to map the VLANs 10 as well as VLAN 20. These two VLANs I want to map. Then I can say instance 2, and with instance 2, I want to map, let's say VLAN 30, VLAN 40, VLAN 50. Then I will use instance 3. I want to use VLAN, and let's say here I want to map 60 only. And let's say instance 4, I want to map VLAN maybe 70, 80, 90, and 100. Okay, like this kind of mapping I have done. Now, similar set of configuration I have to do on all the switches. Okay, so I'll just copy this configuration. Okay, so I changed the mode. I set the name. I set the revision number. Then instance mapping. So these are the comments. Okay, so these same comments I will just put up on all the switches. Okay. Global configuration. Global configuration. Here, here, here. Okay, so same configuration I have done. Now here I'll show you something, right? If I use the command show spanning tree right now, so you can see I'm getting information for MST 0 only. Okay, let's wait for a while. MST 0, right? And here, if I say show spanning tree, here also MST 0. And here if I check show spanning tree, here also MST 0. I'm not getting any other information. Okay. And if I check show spanning tree MST configuration, here you can see that I do have the instance to VLAN mapping. So even if I am having instance to VLAN mapping, why I don't see the spanning tree output here? The reason is because here the VLANs, if you see VLAN 10, 20, 30, 40, 50, they are having different VLANs. And the ports here, these ports, by default, they are working as what? Access port, and they are part of VLAN 1 only. So they will not transfer any data related to other VLANs. So what I need to do, I need to make all these interfaces as trunk. Okay, so I'll use one comment. Configuration terminal, interface range v0 by 0 to 1. Then I'll say spanning tree trunk encapsulation dot 1q. Then switch port mode trunk. Okay. exit, exit. So let's go and do it. Once I'll configure trunk here, then you will see I'll start getting the output. Okay, yes, switch port trunk encapsulation, not spanning tree, sorry. Okay. So now we will see all the output also. So if I see show spanning tree now, you see I have MST0 information. Now I have MST1 information also. Now I have MST2 information also. I have MST3 information also. I have MST4 information also. Okay, and on all the switches, I will see the same thing. Show spanning tree. MST0, MST1, MST2, MST3, and MST4. Okay, and the same thing here. If I say show spanning tree, MST0, MST1, MST2, MST3, and MST4. Okay, then we say that, okay, what we can do is we can, for different instance, we can have a different root bridge also, right? So yes, we can have it. We can just use the command. Okay, this command here, either you can change the priority or you can use what? You can use this one. That we can say root primary and secondary for a particular instance. So what I'll do, let's say for MST0 and 1, okay, if you see our topology, for MST0 and 1, switch 1 will be there. For 2 and 3, switch 2 will be there. Okay, and for MST4, switch 3 will be the root bridge. Okay, so what I'll do here, switch 1 by default root bridge for all of them. So here I'll say that for a particular instance, we can keep it. So global configuration mode, spanning tree, MST, and then I can give the instance number. So let's say for 2 and 3. Okay, then I can set the root. And then let's say primary. Now for 2 and 3, switch 2 will become the root bridge. And for instance 4, okay, so I'll say spanning tree, MST, instance number 4, root primary. Sorry. Okay, so for instance 4, your switch 3 will be the root bridge. So now if I check, so earlier if you check, for all the 4 instances or 5 instances, you can see MST0, this bridge is the root. MST1, this bridge is the root. MST2, this bridge is the root. MST3, this bridge is the root, and MST4 also, this bridge is the root. That means only switch 1 was root for all the instances. But now if I check, if I say show spanning tree, for MST0, switch 1 is the root bridge. MST1, switch 1 is the root bridge. But MST2, somebody connected on interface Z0 by 0. So with switch 1 connected on interface Z0 by 0, who is connected? Switch 2. So this guy is the root bridge. Okay. For MST3 also, this guy is the root bridge. For MST4, who is the root bridge? Somebody connected on Z0 by 1. So with switch 1 connected somebody on the Z0 by 1. Switch 3 is the root bridge. Okay. And here you can check.
It's a primary, no, sir? It's a primary.
Yes, primary.
Yeah. Okay.
Okay. And here also we can check exit. Either you can change the priority also, both the same scenarios there. So if I say now show spanning tree on switch 2, you can see MST0 and 1, it will not say that I am the root bridge, but for 2 and 3, this bridge is the root. Okay. And For MST4, somebody connected on Z0 by 1. Switch 2 connected on Z0 by 1. This guy is the root bridge. Same thing here. Okay. So if I say exit, show spanning tree. MST0, this is not the root bridge. MST1 also, MST2 also, 3 also. But for 4, you see, this bridge is the root. Okay. This is clear. Yes or no?
Sir, what is a revision number?
Revision number is just the version number of the configuration, you can say. Okay. Like if you see here, the version number is there. That is something that you configure for the configuration only. Okay. And this must match.
Okay.
Okay. This is a requirement that in a particular region, how many times the configuration has been revised. So what is the configuration revision number or configuration version number? Okay.
Okay.
Right. So what we understood that, okay, let me mention the configuration also here. That how do you configure MST? So first of all, you change the mode. Okay. You say spanning tree. Node MST. Then you say spanning tree MST configuration. Once you enter the configuration mode, then you say name, and here you will give the reason name. And then you will say revision, and here you will give the revision number. Then after, you will say instance ID, VLAN. Okay. And here you will give the VLAN ID separated by comma. Separated by comma. Okay. This is how you can configure. Then if you want to change STP priority, because if you want to alter the root bridge, in that case, so you can use the command spanning tree MST. Here you will give the instance ID. Then you will mention about priority, and here you will give the priority value. Okay. And also to change the root bridge. So both the things we can do to change the root bridge only. Okay. The first thing you can do is change MST priority, and number 2 is make a switch primary root bridge. So you can mention the keywords also. So you will say spanning tree MST instance ID root primary or second. And the default priority will remain, 32768 only. And since I'm giving you this thing, so this note is also important. Clear? Then after, you can also in MST also you can manipulate the cost same way, spanning tree MST and then cost. Okay, for a switch. And another thing I need to tell you here is so you can see here the long mode, right? This is used in the MST. The long mode cost, this is used in the MST. Okay, so for 1 Gbps in the short mode, the cost was 4, but in the long mode, the cost is what? 20,000. So if you take a look here, what is our cost here, right? So if you take a look at our cost, do you see the cost? The cost is 20,000. Okay, so you can say that MST uses long mode cost. Okay, let me mention here only. So we can manipulate the cost, okay, to decide which port will be the alternating and loop and like that. MST utilizes long mode cost. Okay. Then VLAN assignment. So these are the common misconfigurations. So there are two common misconfiguration within the MST region. You might do, you might assign wrong VLANs, okay, or you might prune the trunk link. That means you might block the links over the trunk. These are the misconfigurations that you can do. So you might face problems due to that. Okay. Then MST region boundary. So an MST region boundary is any port that connect to a switch that is in a different MST region or that connects to, either STP or RSTP BPDUs. So that is the boundary. That means beyond that, your MST region cannot travel. That means MST traffic cannot travel. MST instances never interact outside the region, and MST switches can detect PVST plus neighbors at MST region boundaries. They can know that, okay, there is somebody available with the PVST plus running. Okay. So propagating CST at the MST region boundary involve a feature called PVST simulation mechanism. Okay. So if you want to propagate your CST topology, okay, around the MST region, so that is a feature that is known as PVST simulation mechanism. So in this mechanism, what happened? It will send out PVST or RSTP BPDUs, one for each VLAN. Okay, telling them that, okay, there is somebody available. Okay, so the PVST simulation mechanism is required because PVST and RSTP topologies do not understand the structure of IST BPDUs. So to make the STP and RSTP understand about MSTP, this PVST simulation mechanism is there. Okay. And when the MST boundary receives a PVST plus BPDU, it doesn't map the VLAN to the MST. It is not going to map. So like kind of you can say that this is not completely, what do we say it? That when your MST will receive, so compatibility is not like 100%. Okay. So when the MST boundary receives a PVST plus BPDU, it doesn't map the VLAN. So whatever the VLAN from that it is coming to, it is not going to map that VLAN to the MST. Instead, the MST boundary will map the PVST BPDU from VLAN 1 to the instance. Okay, so if it is coming from other VLANs, it's not going to map it. Okay, but if it is coming from VLAN 1, then it will map it to the instance. it only does this when it receives a PVST BPDU on a port. Okay. Then there are some design consideration that there are two design consideration when integrating MST in a PVST and RSTP environment. First is MST region as the root bridge. MST region is not a root bridge for any VLAN. Okay, these are the two consideration. That one is MST region is considered as the root bridge, and second one is MST region is not considered as a root bridge, because to the other protocols PVST and RSTP, your MST region will be, they will understand the MST region as if this is a virtual switch, single virtual switch. Okay, so when your MST region is considered as the root bridge, the MST region as the root bridge ensure that all region boundary ports, they flood the same instance BPDU to all the VLANs in the PVST topology. Okay, that means this region has to flood, okay, same instance ID BPDUs to all the VLANs. Okay, not different. Then this makes the instance preferred over any other switch in the PVST topology. So like I said, this will look like, okay, this is what, that this is the single switch, single virtual switch, because all the switches in the region will, advertise the same instance ID, right? So this will give more preference to this. And what will happen? The MST region will appear as a single device, and PVST switches will detect and place the alternative link into a blocking state. That means if with one region, see, these are two different switches, right? But to the switch 3, it will look like, okay, this is a single virtual switch. And what they will do, they will put this port in the blocking state. So this will be a condition, as if this switch is having two links with the first switch, that is the MST region. And when it is not the root bridge for any VLAN, so in the situation that your MST region is not a root bridge for any VLAN, the MST region boundary ports can only block or forward for all VLANs. Okay, either they can block all VLANs or they can forward all VLANs. There is not an option to load balance traffic, because the IS instance, that means internal spanning tree instance, must remain constant. So either all the VLANs will be blocked, either all the VLANs will be forwarded. Okay, if the MST switch detects a better BPDU for a specific VLAN on a boundary port, the switch will use the BPDU to guard the block port. Okay, so this is called PVST simulation check, and it is done to ensure a loop-free topology. So this is again one more design consideration. Okay, so this is all about your MST. So these are the two considerations when your MST is becoming the root bridge. And if your MST is not the root bridge, then either it will forward all the VLANs or it will block all the VLANs. Okay. While if your MST is the root bridge, then your MST region switches, they will forward the same instance ID to the PVST or RSTP. Okay. And this will look like it is a single switch, and this switch will put its port as a alternating port in the blocking state. Clear? Because they want to avoid a loop. That's it. So this is all about your RSTP and MST. Any doubts? Yes or no? All right. So now we are left with the topics. Let me check what all the topics are left. Okay, so STP is done. We have Ether channel, FHRP, and L2 security. So let me stop.